You know, the last session of the day, I want to make this really interesting, so I want to ask everyone to imagine for a second that you're not a facility manager in the healthcare facility management business, and sort of take yourself out of that and imagine that you're trying to figure out, how do I optimize facilities in general? And so, I mean, I think Jordan did a great job of giving us a grounding of what Internet of Things is. How does that apply to buildings? So I'd like to start off to think about, again, all these words that are flying around for us to kind of get our mind wrapped around, understand. It isn't so important about understanding that you know how to say those words. It's more about understanding, how do I implement and do something about that in my facility to start the progress of moving forward to all those things we're talking about. Easy to talk about Internet of Things, talk about big data, but then what do you do with all of that? So I thought that I'd introduce HCA by just using illustrations, so we're talking about data, and I thought we'd show what our size related to the amount of data that we have stored. That's a great way of telling the story how large we are. So that planet, Neptune, represents about 30 petabytes of information. And so to give you an idea of reference, if you look at the Library of Congress, that's going to be around 10 petabytes. But if you look at Google, see how large Google is? It's a huge information source. So hospitals are trying to get their minds wrapped around their own data. So all the data that HCA has, we have actually a chief data scientist that is looking at how to analyze data and then put some trends and studies to that together. So, but let's talk about how this applies to buildings, because that's what we're here to talk about. So I'm going to propose to you the idea of flying a building. Now that sounds kind of a crazy way of looking at it, but if you think about it, sometimes, as I said at the beginning, imagine you're outside of your industry and look at something else. We've already used the example earlier today about what it's like to look inside of a cockpit in the area of a sterile cockpit environment, but think about what airplanes are doing all the time. They have basically two systems that are going on in that airplane. The first is that you have a pilot that's using the navigation system, the avionics, and all the systems that tie it together so the pilot has situational awareness of flying the airplane. Well, think about that as one aspect of data coming from the system and managing the system. But the other is also coming out of the jet engine itself. You may have heard that there's actually data that pushes up to a satellite, and then from that data, there's additional analytics that have nothing to do with flying the airplane really whatsoever, but it's great to understand how well that engine is performing. I'll talk about that more here in a minute, what that means. So you got these ideas of these meters and then this data coming through, and then we're trying to figure out, okay, so what do I do with the data that comes out of a building? If I'm kind of thinking about it like an airplane. You've got these edge devices, these point sensors that are there monitoring things that are coming in to manage all this information. And back to the illustration of showing the jet aircraft and the avionics, if you think about this for a minute, there's concern about the security of your building automation system. So I would propose that really there needs to be a very hardened, reliable system that's running your buildings, much like that in the avionics of an aircraft. You wouldn't want to, fly your airplane and run it on the internet and hope that everything comes together on your flight here today, would you? And hope that nobody hacks into that system and then, it sends your plane in the wrong direction. So you need a hardened building automation system, but then you need to augment that with so much more information, with sensor points you can add to the system going toward this big data, Internet of Things thing. So you can see that there's these steps you have to go through of how you get the edge devices to move to some kind of a network, securely moving it to a place where the data gets accumulated, and then from that data you're pulling apps out to get the information for your use and application. So again, looking at this whole area of, you may have heard, how many have heard of unstructured and structured data? Have you heard that term? Do you know what that means? It's kind of I asked our chief data scientist, tell me the difference between the two. And really, in a lot of regards, unstructured data is that you really don't know what it means. I mean, you might get a temperature sensor reading, but where is it from? What's it represent? What's it controlling? And how do I get that information and do something with it? And I shared the example. It sounds like it's kind of like a barrel of monkeys. You're trying to reach in and get data out of there and trying to get the right ones to have it all string together and make sense out of that data. So it's really around how to get the data into a format that makes sense. This is not an easy feat, because you've had to have people that understand how they're going to query the data coming out of the system to analyze it into some kind of action-based methodology in which you apply. That's where we're starting to get to the complicated part of big data, is where to get it, how to get access to it, and then what to do with it. So I want to just talk about data in general, about how you need to look at it or how it can be misrepresented to you as you're looking at it. So the first area to talk about is circumstantial data. How many of you would, I want to tell you a story about a situation where you, of a person that was worked in a wood manufacturing facility in a furniture making location and realized that, hey, I need to take some of these wood filings home with me on a project that I'm working on. So he went and asked his supervisor, can I take the end of day wood filings home with me? We just throw them away anyway. The supervisor said, sure. So he gathered them all up, put them in a big gigantic box, set in a wheelbarrow, walked out the front gate, and a security officer stopped him and said, hey, what's going on here? You're taking that box of stuff out here. What's going on? And he said, well, I checked with my boss, and he said I could take these wood filings home with me and use them at home. He said, I don't know, something doesn't sound right here. Let me check inside the box. So he reaches inside, looks, and nothing but wood filings. Everything is good. Well, he does that for 2, 3, 4 days. The security person says, this just does not seem right. So he stops the guy again, box full of wood filings, and says, okay, tell me what you're doing. Something just doesn't seem right. He opens up the box again, looks in, just wood filings, and the guy says, I'll tell you what, security guy says, if you tell me what's going on, I promise you will not get in trouble. So what are you doing? He says, well, I'm not actually taking and stealing the wood filings, I'm taking wheelbarrows as part of my process of getting them out of the warehouse. So you just think about how that happens in your organizations, because we get so used to seeing the same thing all the time, the same data, the same information. Are we getting blind to the things that are happening around us? Missing data. So I had an opportunity to talk with the head scientist that analyzes jet engine data from GE. So I was serious about flying this idea of the building concept, so I went ahead and got a hold of him and talked about this idea of how they get data out of jet engines. And one way in which they get data is snapshot data. So data comes in usually when the jet is taking off, when it's climbing, at cruise, descent, and landing. And they call this snapshot data. So you can imagine when you look at something for a very small period of time, then don't look at it again, that you might possibly miss something like this. So if this pops up there, stop sign, he said there's all kinds of information that comes up during those missed segments of data capture that they realize later by having more data coming real time, they get the information. I didn't know this, but I thought data was always streaming up the satellites real time. Well, that's too much bandwidth to use, so what they do instead is they gather the data on the plane. When the plane lands, they download the data, and then they do their analysis around it. But from that, they were able to find out, how does a pilot fly the plane? How better can we do maintenance on the jet engines? Are there any problems that seem to be evolving because of the jet engines? But take that idea to a building. The same application can absolutely be true. They call it analytically based maintenance. So, I talked a little bit more about, when you say analytical based maintenance, what does that mean? Well, that's just doing the right amount of maintenance when you need to do that maintenance. So if you think about that in a building or in a jet engine, if you undershoot or overshoot maintenance, those are both bad. If you undershoot, you could spend more money later by not fixing it now. It could be dangerous and malfunction. If you overshoot something, it costs you more money and also puts it at risk by you tearing equipment down more often than you're really necessary to do that. So be aware of the data segments. Low resolution data. You see what I'm trying to get to here? I'm trying to sell the idea that people need data scientists to look at all this stuff that's going on. Well, then you can see what's going on, but you have to have that clarity and that granularity of just like a picture when it's pixelated and it becomes clear, the image becomes more obvious. Non-correlating data. I mean, you can say, well, the trends seem to be down, and you try to pair that up with a whole bunch of other things, which has no relation whatsoever. Or likewise, if data is going up. So you have to be certain if you're looking at data that you're making sure the right analysis as to how you're looking at that as well. Unpredictable data. So what do you see here? Does it look like 4 round circles? See your mind kind of, so how are you looking at the data? Is it clear how you're studying the information going forward? Another important thing to be concerned about. So in this whole area, this whole journey of connecting, getting data, connecting it, pulling it together and analyze it, I'd say right now we're in this whole area of uncertainty. A lot of fragmented ways about going about doing that. A lot of things yet to be learned and discovered. A lot of things have to be done to reduce the cost down where it's affordable facilities to be able to put this advanced data analytics in place. But I can assure you it's coming together faster and faster all the time, where there'll be a point in time where that will be a very standard practice to go into a building, add literally hundreds of sensors, connect them and plug them all in together to run your analytical packages around that. So I leave you, this quote was used already today. So it's interesting that we have so many, minds here that have experience and exposure and expertise in this. And I leave you with the idea of what Eisenhower mentioned. You saw that quote today, that plans are nothing, planning is everything. And I want you to think about that when you look at the terrain ahead, are you looking at just a map and just trying to guide your way through that, or navigating yourself through the terrain that goes with that? Because this journey we're in it's going to be some peaks and valleys, some lessons learned, some experimentation. This whole area of disruptive innovation, it's a very interesting topic to talk about, because when you think of disruption, a lot of times people can confuse disruption with it's just sustaining innovation and not disruptive. Disruptive is something in which it fails to exist the way that it does any longer, and then changes dramatically into something completely different than we haven't seen before. So I just ask, get ready for the terrain. It's going to be a fun journey, and enjoy your time. Thank you.